Is just a chart of a frequency distribution. That's all it is. It's a bar chart of a frequency distribution. However, you'll notice in this example of histogram, I don't have any gaps between my bars. So in a histogram, you certainly use the boundary. Okay, so well, in short, a histogram has no gaps. That's what I want you to know. All right, get rid of them however you can. All right, so there are no gaps between the bars unless, of course, as we see in our 1, 2, 3, 4, 5, 6 class, there was a frequency of 0. Okay, then we can say there's a little gap there. Okay, but it's a bar chart of our frequency distribution. A relative frequency distribution, instead of having frequencies on the axis, on the vertical axis, would have relative frequencies. On the vertical axis. Okay, relative frequencies on the vertical axis. The difference between the two, there's no other difference otherwise. So you should note that the shape of a frequency distribution versus the relative frequency distribution, they're the same. Okay, it has the same shape. As a frequency distribution. Okay, and then this is where this would be even easier for us to determine something about the shape of the data. Okay, what does the data look like? Would you say that this data is normally distributed? No, it's not. Okay, we don't have our highest value in the middle and tapering off as we go above and below that. Okay, in fact, we would call this data, for reference, we would call this one skewed right. We'll talk about that in a minute. But I think, when I think about skewed, to remember the difference between skewed right and left, I think skew means skinny. So it's skinny on the right. All right, skewed right. Our data looks more like this. All right. What else can we note about our data? Most of our values are where? Okay, that 20 would be the midpoint. So, about 20 years old, we might say. Okay, and the ages tend to generally decrease. Do we have any, remember we talked about CVDOT, what was the O for? What was it? Outliers, very good, outliers. Do we have any outliers? Maybe, it looks like we may have one outlier, one extreme value in our data. All right, very good. On the test, of course, I'm not going to ask you to make a histogram unless I give an out-of-class portion where you would do that in Excel. You will have the opportunity to do it, whether it's as part of the test or an additional assignment. We'll figure it out. Okay? All right, so we've been talking about different distributions, and so here are some of the most common ones. We've got data that's normally distributed or bell-shaped. This is data that's uniform. This is data that's more skewed right. Okay, skinny on the right. And this is data that is skewed left. Okay, skinny on the left. Some things we've already seen, skewed right data, the ages. Have we seen anything that was normally distributed where we think most of the values would tend to happen around a center value and then you could kind of go up or down from there? Data values, any variable, anything that we could collect that we might expect to have a normal distribution. What about body temperature? Okay, we would expect most body temperatures to be around what is it, 98.6 or is it 96.8? Okay, 98.6. And then, they kind of, some would be above that, some would be below that, but they would taper off from there. So that's an example of bell-shaped data. Uniform data, we'll have the opportunity to simulate rolling a die, a single die. If we did that, 1,000 times, we would expect, if it's a fair die, that the number of 1s, 2s, 3s, 4s, 5s, and 6s would be about the same. Okay, so that's an example of where we might get uniform data. Or, as we saw, the last digit of data collected, like numbers from a phone book. We would expect, if we looked at the last digit of a number from a phone book, we would expect that that would be approximately uniform, right? Because those numbers are pretty much randomly generated. Okay, so be aware of these as we describe things and describe the distribution of our data.